It's as easy as can be, just have to take dx dt. I will derive, hey, hey.
The derivative of a constant function is d dx of c equals 0. This will always be true no matter what the constant. The derivative will always equal 0. For example, to find the derivative of y equals 5, you use this rule and you know that dy dx equals 0.
The rule is d dx of x to the n, which equals nx to the n minus 1. This is saying that the derivative of x to any number n will be equal to n times x to the power of n minus 1. To find the derivative of y equals 4x to the third, you use the power rule. First, bring the 3 down front, so it will be 3 times 4x. Then minus 1 from the power, so that x is 2, so 3 minus 1. When you simplify this, you get dy dx equals 12x to the second. The multiple rule is d dx of c times u equals c times du dx. This is saying that the derivative of any constant c times any function u is equal to c times the derivative of the function du dx. This concept is used to find the derivative of 7x. 7 is a constant and x is the function, so you get 7 times the derivative of x, which is 1. Then simplify, and dy dx equals 7.
The sum and difference rule is d dx u plus or minus v equals du dx plus or minus dv dx. This is saying that to find the derivative of two functions when they are added or subtracted, you just take the derivative of each piece individually and then either add them together or subtract them. For example, you use the rule when deriving y equals 3x squared plus 22x. First, you would find the derivative of 3x squared. You find this by using the power rule. You bring the 2 to the front and get 3 times 2, which is 6, and then subtract 1 from the power and you would get 1. So the derivative of that piece would be 6x. You would then find the derivative of 22x by using the constant multiple rule. You do 22 times the derivative of x, which is just 1, so you get 22. Then you add both of those derivatives together and you get dy dx equals 6x plus 22. You do the same when subtracting the two functions. For y equals 6x cubed minus x squared, you find the derivative of 6x cubed first. By using the power rule, you bring down the 3 and do 6 times 3 and then take 1 away from the power and get x squared. The derivative of 6x cubed is 18x squared. You also use the power rule to find the derivative of x squared. You bring down the 2 and times it by 1 and then take 1 away from the power and you get 2x. Then for the answer, you get dy dx equals 18 squared minus 2x.
Product rule is d dx of u times v, which equals u times v prime plus v times u prime. This is saying that when finding the derivative of two functions that are multiplied together, you take the first function u and times it by the second function's derivative, which is dv dx. Then add the second function v times the first function's derivative, du dx. The derivative of the quantity x squared plus 7 times the quantity of 2x to the third, you have to use the power rule. U would equal x squared, v would equal 2x to the third, u prime would equal 2x, and v prime would equal 6x squared. Then you plug the numbers into the equation of u times v prime plus v times u prime. When you do that, you get x squared times 6x squared plus 2x to the third times 2x. This turns into 6x to the fourth, which equals 4x to the fourth, which could be added together to get dy dx equals 10x to the fourth.
The quotient rule is d dx of u divided by v equals v times du dx minus u times dv dx over v squared. This means that when deriving an equation where one function is divided by another, you use the function on the bottom, v, times du dx, the derivative of the function on the top, minus u times dv dx, the derivative of the function on the bottom, all divided by v squared, the function on the bottom. To derive the equation y equals 2x plus 5 divided by 3x minus 2, you need to use the quotient rule. U would equal 2x plus 5, v would equal 3x minus 2, u prime would equal 2, and v prime would equal 3. Then you plug the numbers into the equation vu prime minus uv prime all over v squared. When you do that, you get the quantity 3x minus 2 times 2 minus the quantity 2x plus 5 times 3 all over 3x minus 2 squared. This reduces to the quantity 6x minus 4 minus the quantity 6x plus 15 all over 3x minus 2 squared. This can further be reduced to negative 19 over 3x minus 2 squared. Here are some practice problems to work on the rules and formulas that we learned today. Pause the video and work out the problems. To find the derivative of y equals 4x to the negative 2 minus 8x plus 1, you use the concepts of the power rule, the constant multiple rule, the sum and difference rule, and the derivative of a constant rule. To find the derivative of 4x to the negative 2, you use the power rule. You bring the negative 2 to the front and times it by 4, and then minus 1 from the power, and you get negative 8x to the negative 3. Then you use the constant multiple rule to derive negative 8x, and you get 8, and then the derivative of 1 is 0. Then you subtract, and you get dy dx to equal negative 8x to the negative 3 minus 8.
The derivative of y equals x minus 1 divided by the quantity 1 plus x squared, you need to use the quotient rule. You get u to equal x minus 1, v to equal 1 plus x squared, u prime to equal 1, and v prime to equal 2x. When you plug those into the quotient rule equation, you get the quantity 1 plus x squared times 1 minus the quantity x minus 1 times 2x, all divided by the quantity 1 plus x squared. This answer then reduces to dy dx equals 1 plus 2x minus x squared divided by 1 plus x to the 4th.
To find the derivative of y equals the quantity x minus 1 times the quantity x squared plus x plus 1 divided by x cubed, you know you have to use the quotient rule because you are dividing. You get u to equal x minus 1 times x squared plus x plus 1 and v to equal x cubed. You have to use the product rule to find u prime, but we can find out that v prime equals 3x squared. Because I'm already using the variables u and v, I'm going to use j and k to represent the two functions I'm using for the product rule under the function u equals x minus 1 times x squared plus x plus 1. You get j to equal x minus 1 and k to equal x squared plus x plus 1, j prime to equal 1, and k prime to equal 2x plus 1. Then you plug it into the product rule formula and get x minus 1 times 2x plus 1 plus x squared plus x plus 1 times 1. This can be reduced, so we know that the value of u prime is equal to 3x squared. Now that you know the value of u prime, you can go back to the quotient rule portion of the problem and continue solving it. When you plug in the values of u, v, u prime, and v prime, you get the quantity x cubed times 3x squared minus the quantity x minus 1 times x squared plus x plus 1 times 3x squared, all divided by x cubed squared. This can be reduced to 3x to the 6th minus the quantity 3x to the 6th minus 3x squared all over x to the 6th. This can further be reduced to 3x squared over x6, which can be reduced again to the final product of dy dx equals 3 divided by x to the 4th.
So for this section, you need to make sure you know these equations by heart. You'll use them the rest of the year. It's a major concept that you need to understand. I'd recommend making flashcards of these formulas because you need to have them memorized.
At first I was afraid, what could the answer be? It said given this position, find velocity. So I tried to work it out, but I knew that I was wrong. I struggled, I cried, a problem shouldn't take this long. I tried to think, control my nerve. It's evident that speed's tangential to that time position curve. This problem would be mine if I just knew that tangent line was what to do. Show me a sign.